Hey guys, this is Britt Castle with another video with examples from the SavvasRealize textbook. This one's example 3 from section 1.1 in the Algebra 1 textbook. And so this question is asking about when we are dealing with rational numbers, whether certain operations are going to create another rational number. So what we should probably do is start by asking ourselves, what the heck is a rational number, right? That's the key part here, okay? So in this fancy green box, I have found the very clinical definition, okay? It's a number that's made by dividing two integers. So in essence, a rational number is just, it's a fraction, okay? That's all that it is. So they are wondering if I can create a number where I am taking one number and dividing it by another, and whether it will create another fraction that is viable. Okay, so we're going to be doing these operations, and the check to see if it's going to be a rational number is we need to look to see if the denominator on our resulting fraction is equal to 0. Because we can't have a 0 in the denominator of a fraction, that's kind of our test to make sure if it's rational or not. So let's start with part A. So part A is asking about a sum. Okay, that means that we are adding together our two rational numbers. So I'm going to add together two fractions. So my first rational number, I don't want to specifically say what it is. So I'm going to talk about it in terms of variables, okay? It is a number divided by a number, okay? Now for this to be an actual rational number, it has to follow the rules of fractions. And the rule of the fraction is you can't have a 0 down here in the denominator. So I'm going to come to the side here and I'm going to specifically say, well, b can be anything, but b cannot be 0. So here's my first rational number. Now my second rational number, okay, I'm going to call it c over d, is going to follow that same kind of rule here. Okay, I cannot have a 0 here in the bottom, so I'm going to say d is not 0. So part A here is saying that I'm finding the sum of those, I'm adding those together, and it's wondering if once I add those together, do I get a fraction that doesn't have 0 in the bottom? Alright, so we have that set up. So now we need to actually add our fractions. So remember, when we go to add fractions, we always want to start by finding what's called the least common denominator. Okay. Usually the easiest way to find the LCD, or the least common denominator, is to multiply together the two denominators of the fractions. So our least common denominators for these two fractions are going to be b times d. So I'm going to go ahead and fill those in. Now to get this first fraction to have a d in the denominator, I need to multiply it by a number that's equal to 1, right? So any number divided by itself is 1. So I'm going to multiply it by d over d. So a times d is ad. And then I'm going to do the same thing to this second fraction. It already has a d in the denominator, so I need to find a way to get a b to be there. So I'm going to multiply it by b over b. So c times b, I'm going to call that bc. So now our two fractions are written, okay, our two rational numbers are written to have a common denominator. Now I'm going to go ahead and add them together and see if the resulting fraction is still rational. Right? So when I add together fractions, that common denominator stays as the denominator. And then I add together the two numerators. I add AD plus BC. Right, now I'm not really worried about this top number because this top value could be anything really. Okay, my biggest focus is down here at BD. So is BD equal to 0? This is where we really have to kind of think about it. Okay, so in order to multiply two numbers and have the outcome be 0, either the first number has to be 0, the second number has to be 0, or I guess they could both be 0, okay? But we want to look, is b equal to 0 or is d equal to 0? Okay, because if they are equal to 0, this doesn't work, and we could say no. But if they can't be 0, we're good to go, and it's rational. Now remember, here at the beginning of the problem, back in the purple phase, we specifically said, yo bruh, these guys are not 0. So because when we defined it, we said that those things aren't equal to 0, that means that this is now a rational expression. So yes, it is rational. So now we're going to check out part B. So part B is now dealing with a different type of operation. Okay, it's still asking about my two rational numbers. Okay, it's still asking about a over b and c over d, where b is not 0 and d is not 0. Okay, we're still asking about those two rational numbers, but we're asking about a product. Okay, a product means that we are multiplying. So I'm going to put my little multiplication dot there. And I'm asking myself, is the fraction that comes out of that, is it rational? Now this problem is actually easier than the first one because multiplying fractions is a cinch. Okay, so you just take a times c, multiply them together, and then you take b times d and multiply them together. Right, you just times across. And so we're in that same situation where we are checking, can b times d equal 0? Is that a thing? And just like above where we said no, those can't be 0, right? We defined it that way. That means that in this situation, BD can't be 0. So yes, this is a rational number. Now part C, I could go through and set up my fractions and, you know, go through the division process, right? Because quotients are dividing. I'm going to show you guys a little trick here. All right, so multiplying and dividing have a very special relationship, right? They're inverse operations of each other. So if I multiply things and I know I get a rational number, because that works, when I divide in two rational numbers, I'm also going to get a rational number because they have that relationship. So because multiplication and division are inverse operations of each other, and multiplication produces a rational number, division will as well. And that works with other operations as well, kind of a hint there. So when you guys go to do your problem set, think about addition. What operation is tied to addition? That'd be subtraction, right? So you can kind of use that logic to help you with figuring out if your answers will be rational or not. But there we go. That's example 3. Until next time.